Hello YouTubers and fellow hams. Well, today we are building a kit. This is the Volt Tattler version 2.1. Comes on a nice little comes with a nice little PC board. Rounded corners, and I don't have one here to measure, but I suspect that would fit just perfectly in an Altoids tin. I think that's actually the design idea. So what is the Volt Tattler? Well, being hams, most of us probably have battery systems that we use for field operation, for emergency power at home, and battery systems need to be charged. And so you've got a charger that maintains your battery, or you charge it up and then leave it, or whatever. Well, what the Volt Tattler does is it monitors a voltage source, and if the voltage gets below a threshold, it sounds an alarm, and if the voltage gets above a threshold, it sounds an alarm. So, and those thresholds are programmable. So you could set it to say 14 volts and 12 volts. And if your charger pushed the batteries too high and the voltage got up above 14 volts, this would start sounding a Morse H for high, 4 dots. And if the voltage dropped below 12 volts, this would start sounding a Morse L, dot dash dot dot, for low, to alarm you that the battery voltage was low. So it's a battery minder. Pretty cool. It's a microcontroller-based device. It comes with a little microcontroller here that we're going to put on the board. It's socketed. It comes with sockets for the chip, which is kind of cool. Fairly small component count. We've got a few capacitors, a few resistors. Piezoelectric buzzer. That will be the alarm. 3 LEDs, red, green, and yellow. The green will flash once per second when it's in operation, just to let you know it's working. The yellow will come on if the voltage is low. The red will come on if the voltage is high. And if the condition changes, let's say the voltage went high and then corrected itself back down, and you didn't get the alarm right away, by the time you get to the device later, the red light would be flashing along with the green light to let you know that the last alarm was a high voltage condition, or the yellow to let you know that the last alarm was a low voltage condition. So you've got a little history. If you had this on a remote thing, say you had your battery stored in the garage, and you came out and you saw that the red light was flashing along with the green light, you would know that at some point it had a high state alarm. So that's kind of cool. It's got some nice design features. The manual for the Volt Tattler is one of the best kit manuals that I have seen in a long time. It has wonderful high-resolution photographs, extremely detailed instructions, nice board layout. You know, when the component list, everything's comprehensive, everything's put together very well. It's as professional of a manual as I have seen for kits. So I'm quite impressed with the manual. So let's get this thing built. Small component count, shouldn't take very long. Let me get the soldering iron heated up. Grab my third hand, and we'll start putting together the Volt Tattler. All right, the first thing I'm going to do is I'm going to get the low profile stuff mounted on the board, which the lowest profile is going to be the socket. So there's a notch. I don't know, for those of you that haven't done chips before, the socket has a notch on one end, and that is pin 1, the pin 1 marker. Pin 1's up here next to the notch. And on the board, there's a little white dot and an angle to show you where pin 1 is. So you want the notch on the socket lined up with that. You could install the socket backwards and everything would still be just fine. You would just have to make sure when you put the chip on it that you get it lined up right. But now, the way I do sockets, I'm going to set this down on my board so the pins are all held through there, and then I'm just gonna touch the solder on the corners of the socket, and then I'll be able to press the socket in to tighten it up. Okay. Now I've soldered the opposite corners. Sorry that wasn't in camera. But what I'm going to do then is I'll put my finger on the socket and I'm going to put pressure on it. And while I'm holding and putting pressure on it, I'm going to touch that solder again. And that's just going to make sure that the socket is pressed firmly against the board. Okay. Now I know the socket is solidly mounted on the board. And we can go ahead with soldering the rest of the pins. So the obvious stuff, you know, you want to be very careful. You don't generate a solder bridge here. These pins are pretty close together. Okay, visually inspect it. Look to see that you don't have any bridges in there, that you've got a nice gap between each pin. And then you can move on to the next step. Now I'm going to do resistors next, which is going to take me a little time because these are quite tiny and some of them I'm not exactly 100% sure of the colors because they're so small. So I'll be measuring each one with my fluke meter before I put it in. So that's going to take a little while. I'm not going to sit here and make you watch me doing that for the next 15 minutes. I'll turn the camera back on when we're on to the next step. Okay, putting these little capacitors on the board. These things are teeny tiny. For example, this is a C5. And on the board, hopefully, there's enough detail where you can see that those leads are just too small, too narrow. Now I could just jam the capacitor in there, but it would be very unclean looking and kind of gross. So what I will do is I will take these leads. Let me see if I can get closer here. So what I will do is I will take needle nose pliers and I will bend these leads out just slightly and then put a second bend in so they go kind of straight down. And then I'll fit them into the holes on the board. This is C5, yep. I double and triple check myself on components on the list to make sure I'm putting the right components in the right places. And now you can see that's a little bit of an angle. That cap is nice and straight. So I have to do that for each of these because they're too small, their leads are too close together for the holes. So we'll just do that for the next one. C2, C5, C6. Okay, I'm going to finish up the capacitors and then we'll come back as we do the solid state components. Alright, all the capacitors are mounted now. Starting to look like a useful device, huh? Now we've got to do 3 solid state devices. One of these is a transistor. One of them is a voltage regulator for 3.3 volts for the microcontroller. And one of them is a low power MOSFET. So we've got to get the right ones in the right places. And I can't read that number. Where's my magnifying lens? Oh, old eyes. Well, there we go. 2N3904. That's our NPN transistor. And that is Q1. So Q1, where are you on the board? Q1, way over here. Okay, the base is offset, so I'm going to take my needle nose pliers. I need to bend the base pin back and down. Okay. Orientation is very important on these devices. Fortunately, the diagrams on the PC board show the flat side and the circular side of the transistor, so you can line it right up. So we'll get Q1 in there. Now, U1 is our voltage regulator. 442, 4A. Okay, so this is Q2. Oh, the holes are drilled exactly like the leads line up. Flat side is clearly indicated. So we'll get that. I've got to bend a couple of the leads out a little bit so it doesn't fall out of the board before I solder it. There we go. And that leaves us with the voltage regulator, U1, which looks like a transistor, but that is a voltage regulator, 3.3 volt regulator. And again, the holes are drilled just the same way the leads are lined up on the device, so I don't have to do anything with the leads to get them to fit. Just got to get them all to go in the holes. There we go. All right, now we'll solder these devices. These are very small solder pads and they're very close together, so be very careful when you solder these components. The other thing I'm going to do is I'm going to alternate. I'm going to do one lead on one of them, one lead on another, one lead on another, and then move around and do that on all three. That way I don't heat one device too much by trying to solder all three of its leads at the same time. We'll do them one at a time on each device. All right, there we go. There's our solid state devices. Trim these leads. Okay, what's next? LEDs. LEDs have polarity and they are marked in two ways. Generally, the cathode is marked with a shorter lead, which you probably can't quite see. One of the leads is shorter, that's the cathode lead. That coincides with, on the LED itself, there is a flat side next to one of the leads. There's a flat, and that's the cathode side, so that's the ground side. And again, on the board, you can see a flat in the drawing. There's a circle with a flat side, so it's easy to tell which way they go. Green, yellow, all very clearly labeled on the board. He did a really nice job on this board. And red. But what I'm going to do, again, I'm going to do one lead on each of these LEDs, and then I'm going to press on the LED on the other side of the board as I reheat the joint to make sure I get it nice and tight against the board. So I'll do one lead on each. And then on each one of them in turn, I'm going to press on the LED, and I can feel it snap up against the board as I heat the solder. You might even hear that on the microphone. Okay, now they're each firmly against the board, and I'll solder the other lead. Okay. And there's our LEDs. Nicely mounted, and as you can see, nice and flat against the board. That's how you do it. One component at a time. By the way, when you're cutting these leads, always aim them away from your face because they tend to go flying, and you don't want to shoot one of those like a little metal missile right into your eye. That would be bad and probably quite painful. Okay, we've got the push button, the header, the piezo element, and the connection socket for power that comes in. So I'm going to go ahead and get those done, and then we'll move on to testing. Okay, the board is done. All the components are mounted. I visually inspected it. I don't see any solder bridges anywhere. We're up to testing. Now, I have not plugged in the microcontroller yet. As you can see, it's just an empty socket there. What they want us to do before we plug in the microcontroller is we want to check voltage and make sure that the regulator is working and we're getting 3.3 volts at the point where the microcontroller is, so that we don't burn it up when we plug it in. Seems reasonable to me. So I've got my bench supply set to 12 volts as per the instructions. The board has this little, well, you can't quite see it. Hang on. There, hopefully you can still see. I'm getting a shadow on the meter. There we go. Up here in the corner, we've got a little terminal strip that we can put wires in and screw it down. Tiny little screws, but I've got a power lead hooked up, and I'm about to hook up the power supply. All right. No current draw when I connected it, so that's good. It means we don't have a short. Now, according to the instructions, I should see 3.3 volts on the microcontroller's power lead. There it is, 3.28. Just what we're supposed to see. Okay, so that's good. We're seeing the voltage we should see. We're not going to damage the microcontroller. So I'll disconnect power and we will install the microcontroller. Now, these DIP ICs usually come from the factory with the pins out at a slight angle, and you need to flatten them against a table or something so they're going straight down. There's an excellent diagram in the manual, which I'll show here, that shows you how to do that. And it's pretty easy. You just put the pins against a table and linearly put a little pressure on the chip to just sort of cinch them down straight, which I have just done. Now I should be able to just drop this right in the socket, make sure all the pins are lining up. They are. And it just plops right in. Now we're ready for the real deal power on test. Isn't this exciting? As soon as I hook up power, we should hear it send a letter R, telling you it's ready. And it did. It sent an R. Just what we wanted to hear. That means that it's operating. So I'm going to put the voltmeter on my supply voltage, and you can see it's at 12.03 volts. The default thresholds on this thing are 12 volts and 14 volts, or 15. Maybe it's 15. So when I decrease it below 12, we should hear it send a letter L. Well, maybe it's 11 volts he's got the threshold set to by default. Okay, it was actually 9 volts, that's right. So when I got below 9 volts, it started sending a letter L. Oh, 10, okay. 10 volts is the default low threshold. Okay, let's go the other direction. Let's take the voltage up. 14. I think it's 15 where it'll start sending an H. And then when I get back down into the safe range, it stops. Now you can see that the red and yellow lights are flashing along with the green. That's telling us that we hit thresholds at some point in the past. So that's that nice history. If you had this out like in a shed or a garage on your battery charger and you came walking out and saw the red light flashing, you would know that sometime while it was out there, it went into a high voltage, over voltage alarm. If I press the button once, That resets it. Now it's back to just flashing the green once per second. Might be kind of hard to see on the camera, but it's flashing once per second. Now, if you don't like those thresholds, if you want your own, which I do, I want my upper threshold to be at 14.3 volts, and I want my lower threshold to be 11.8 volts. So to set the thresholds on the device to what I want them to be, there's a programming mode. So to enter programming mode, I hold the button for 3 seconds. It will send a Morse E, a single beep, to let me know that it's in programming mode. And then I will set my high threshold voltage. It'll start sending an H, telling me it wants the high number. And I will dial the voltage to the threshold I want, and then you press and hold the button for 3 seconds, and it'll beep an E, a single beep again. And when you release it, it'll start sending an L, and I'll set the low threshold voltage. And when I'm done setting these, then my thresholds will be programmed into the device, and it will monitor the voltage where I want it to monitor it. So let's enter programming mode. 3 seconds until it sends an E. And it wants me to set the high voltage threshold, so I'm going to take the voltage up to, let's say 14.5 is where I'd want it to send me an alarm. In my experience, if you hit 14.5 voltages on a charge cycle, you're charged. Okay, so I press and hold it for 3 seconds again. Now it wants the low voltage, so I'm going to take it down to 11.5 is where I want to be alerted that there's something wrong. Hold it for 3 seconds. Oh, it's telling me the voltage is low. Huh. Yep. So when I get down to 11 point whatever it was, 47 or so. There we go. That's my new threshold. What about the high voltage? I get up to 14.5, it should start signaling high. So there we go. The Volt Tattler is now programmed for what I want it to monitor, and it's ready to go on my battery system. So there you go. That's the Progress Direct Systems Volt Tattler 2.1 kit. I'll put the link to their website in the description below the video. I'm going to feel pretty happy having this on my battery system. I had an incident not too long ago where I had a fuse blow, and I wasn't aware of it, and I ran one of my batteries way down. And then I had a long period of recharging it. Fortunately, it didn't damage the battery. But if I had this in place, I would have known that I had a problem before my radio went dim, which could have hurt the radio too, operating it at low voltage. So this could have saved me some headaches back then, and it probably will in the future. So I hope you found this interesting, and if this looks like something you can use, the link is down in the description below where you can go pick up your own Volt Tattler. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.